So, what is a polymer? Well, it's a substance made up of many repeating units, called monomers. But really, what is that? Here's an example. This is tetrafluoroethene. It's formed of 4 fluoride atoms, bonded to a carbon pair. This is a monomer, a simple molecule that joins up to form polymers. But how do you get from this to a polymer? That occurs via a process called addition polymerization, when you take the carbon double bond of a large amount of these monomers and apply pressure, with a catalyst, opening the bond up, creating more bonds on either side of the carbon chain, thus allowing it to join with other monomers, forming a polymer. In this case, you would form polytetrafluoroethylene, commonly called Teflon. It has non-stick properties, thus it's used for pots, pans and even waterproofs. How would you show this? Simply add an N in front of the monomer and, using an arrow to show the reaction, convert it to the polymerized version of itself, where the carbon double bond is broken apart, creating bonds stretching out from each end of the carbon chain, to show the repeating nature of the polymer. Finally, place this in brackets, adding an N next to this. Some more examples of these addition polymers include polyethylene, used in plastic bags and bottles, polypropylene, used in plastic crating, furniture and ropes, and polychloroethylene, known more commonly as PVC, or polyvinyl chloride, used for piping and the vinyl records of 1970. The other type of polymer are condensation polymers, which involve monomers with 2 functional groups, thus with different structures and properties. When they react together, they bond, forming polymer chains, and each losing part of their structure to form a small molecule, such as water. An example of this process are polyesters. These form when a dicarboxylic monomer reacts with a diol monomer, causing both hydrogens from the diol and hydroxides from the dicarboxylic to separate from their monomers, bonding together to form 2H2O. The remaining structures likewise bond together, forming a unique bond of oxygen, carbon, oxygen, known as an ester link. This is a repeating structure of the polyesters, giving it its name. Other examples of condensation polymers include polyamides, from the reaction of a carboxylic acid and amine. Proteins, from amino acids, which themselves are formed from an amino group, NH2, and a carboxylic group. And DNA, which is what makes you. However, what happens to these plastics at the end of their lifetime, after we've chucked them in the bin? Primarily, we are often still sticking to the easier method of disposal: landfill. Currently, we are dumping the majority of the 2 million tons of plastic waste we produce into these landfill sites, taking up land and polluting the environment. Worse still, some companies attempt to remove this waste via combustion, attempting to use it as a fuel, often releasing toxic gases in the process, thus adding further to the pollution. Plastics are derived from crude oil, a finite, polluting resource used by humanity. We need it for more than just plastics. We use it to fuel our cars, and heating our homes. As our oil reserves dry up, delaying this issue is essential, one method being polymer recycling. This vastly reduces the amount of non-biodegradable waste we produce, as well as the carbon emissions we give out, generally using less energy and crude oil in the long term. However, it's not just a simple cut and dry choice. Recycling requires time and effort. Each polymer can only be recycled a finite number of times, and separation of each individual plastic in a product is necessary, often increasing cost. However, in our increasingly plastic-reliant society, do we really have any other choice?